Hello, good evening. My name is Muntasir Muhammad. I am an MEP design engineer. Right now, I'm working as a freelancer, uh, as a instructor. Yes, uh, actually, right now I'm working with many engineers. Today, allow me to take you through this course and to know exactly what you expected to learn by the end of this course. Okay, as I mentioned on the text or on the WhatsApp that this course has involved three stages or three levels, and also allow me to add like extra information that every stage is depend on the previous stage. For example, like the manual calculation, you can say the AutoCAD and softwares is depended on the manual calculation. You can say the AutoCAD and softwares besides the manual calculation are like strong or solid background about the technical. I think you will understand me during this lecture when I came across those those knowledge or this knowledge to explain more. First, let me show you one of the examples that you should be able to do after you finish this course. For example, here we have the HVAC manual calculation. So allow me to explain how you can make it and even what is it. When I say HVAC manual calculation, it's here. Okay. So imagine now you have a project for HVAC. Okay. So how are you going to select your HVAC system? So here it is like an example. Uh, Actually, for all our working on MEP, we are depending like on the standards and code. We have two types of standards. We have like the international standards and the local standards. For example, we have like for HVAC we have ASHRI. I think you know ASHRI. You know ASHRI. It is here in this page, which I was using for my manual calculation. So when I say manual calculation is to try to estimate your project depending on what? On standards. However, if you are working on like for example on Gulf or in Saudi Arabia, you should use the local standard or the local code. So here we have the ASHRI. It is like the American Society of Heating and Refrigeration and air. Yes, and air and also like the ventilation, all related to this American standard. We have also SMACNA. SMACNA is related to how can you design duct and the velocities on the duct. All those we use them in our manual calculation. So for a start, when you try to, for example, here I'm talking about the example for to design like an air condition system for 10 flowers. So first I will identify the scope. I will identify the temperature control, or what is the temperature that I need to select. For example, say it is 23 or 24 according to standard. It's supposed to be 24 degrees Celsius like this. And the air movement, even we have like minimum or maximum velocity according to the type of the building, air cleanliness, noise criteria. we can measure the noise by using the decibel, pressure differential, all those you will take in your consideration during your designing. This is like the first estimation. So when you come to estimate for HVAC, we are using matrix or the selection criteria. Okay, according to Ashley, you should take like all the scopes, air temperature, available space, partial control, because some of the HVAC system, they can work for the whole building at the same time. We have like, for example, the bucket unit. You know the bucket unit. I will show you after this slide. I will show you a number of the picture or all types of HVAC system. We have the bucket unit, and even we have the central system, or central air water, central all water, central all air systems. So for the bucket, you can serve all your zone or all your space on the same condition. You don't have the access to change it to be like partial control. But for central, each room can have the access to change the temperature, to change even the speed of the device, of the fan coil. Okay, so even you will take on your considerations architecture, because for some systems it couldn't be like convenient for more than 5 stories, even the bucket unit, because it has like big duct, which it could not be able to be installed on like very high building. When the building become like very high, so the duct will be like very big. Also, we will take on your consideration the maintenance. Is it going to be like very expensive, or how it will be? Available capacity. It is like, is this device or this HVAC system, is it going to serve me to provide like enough capacity for this building? So you will create the selection matrix. Okay, selection matrix. This is the selection matrix. Uh, You can say in HVAC we have more than 12 system: rack, BTAC, evaporative, spirit wall, spirit cassette, ducted spirit, VRF. I think you know VRF. VRF, it is a variable refrigeration flow, and we have also the bucket unit, central all air, central all water, central air water. Let me just give you like brief information about the difference between the air, all air water and all water. This is for central. Okay, when we talk about the the all air system, we are just talking about AHU. It is the air handling units. It will be just air handling unit, which we will use to cool or to maintain like the comfort room for the people inside the building. Just we will use air handling unit. This is in all air system. When we talk about all water system, we are using FCU, fan coil unit. Fan coil unit. Okay, it is a device which you can put inside the room, and also you will have like a chiller which you can serve, and every time we'll call the water to, and it will be like a circulation system going inside the room, and even the water will come back again. There is a pump. Yeah, it is like this fan coil unit. uh, we have the last type. It is all In this type, you will use the fan coil unit and AHU at the same time. You will have fan coil unit for cooling or for conditioning. As well, you will have AHU for fresh air, because for some building we need the fresh air. Okay, let us try to see how can we use this matrix selection. For example, you will use the tick and cross method. Now imagine we have like a building, like it is like 10 stories or 10 floors. Do you think that the rack system is suitable or is it convenient? So uh, when we talk about the air temperature, is it able to provide this temperature? We are talking about 24 degree Celsius. So yes, for the rack system, it is okay to provide this temperature. So I will tick it, and then available space. Can I find available space on this building for 10 floors? Is it available? Yes, it is available. You can put it on the wall. And when we talk about the partial control, we are talking about you can get an access to control this device as an individual device without sharing with other device. So we have just one zone for each room. What about the architecture? For the architecture, this device couldn't be accepted. For example, when we talk about building like Burj Khalifa or the Khalifa Tower, so for those building which has like sophisticated appearance, you can't use this rack system because it will affect the architecture appearance. The feature wouldn't be like that the architectural expected to be. So for the architecture, the rack system is not suitable for 10 floors, for more than 10 floors. What about maintenance? Now imagine if we have like a failure in one of those devices. For example, if it is on the 8th floor, ninth floors, fifth flowers, how can you make this maintenance? You should go and you should try to get a scaffold, and this process will be like very hard, like it will cost you a lot of money to fix one device. So for 10 flowers, this device can't be accepted. About the available capacity, it could be like provided uh, any capacity that you need. The climate, if we talk about our tropical, it could be accepted to rack system. And by the end, if I have one cross here, so the last result will be cross. I will do that for the PTAC, evaporative, spirit, all of them. So by the end, I can find that I have three selection. Three of them have got the last result was okay. So I can't go just and select one of them randomly. The next step I will make like economically comparison like related to economic. Which one will be like the most cheaper? I will take in my consideration the first cost. I'm talking here about the initial cost, how much it will be. We will try to estimate how much VRF will cost me for the initial cost, uh, like how long will be the lifetime, the energy consumption, the maintenance. So I will try to calculate the total running cost as well. I will calculate all of them. So by the end, I can see here VRF is expensive, and then I have here central all water is the cheapest one, and also I have the central air water, it is a little bit higher than the all water system. I will select it. Okay. So after I select, this is the second step. I will come here to try to just to draw using like the ruler and the pencil to know exactly where is like the place of my devices. I don't know, maybe I forgot to show you the plan that I was working on, but it is like a residential plan or like a small building for like just the dwelling building. So this is my plan, and here where I will put the FCU, I will put the FCU. Okay. So after I put the FCU, I will connect the FCU using the duct, and here we have the diffuser. Diffuser, the place where the air is distributed to the room. Here I have the diffuser, and even I have the piping. Because I have the piping which will go to the chiller. Just I will estimate. In this stage, I will use equations and calculations to know, like for example, how many devices that I need for this building, to try to imagine how this the system, the HVAC system will be like. What is the shape? How is the shape? So after that, I will try to calculate the load. So according to Ashri, even they give us like one chapter where you can try to estimate like the load calculation, or the heat load calculation according to the building, and even according to the activity of the people inside the building. So here even we have the number of people in each room. Here we have the number of people. For example, in GF1 here we have 2 people. We know exactly how many people inside the room, and we know the area. Okay. So according to Ashri, they are saying that you can estimate between 500, okay, until 800, okay, BTU. You know BTU, it is a unit of heat according to the British unit, BTU per hour. Okay. So when should I select 800? According to Ashri, I will select 500 if the activity is low. For example, if it is like uh, residential building, educational, I will select 5. But if it is like gem, you know gem, if for example, if this place is gem, or if this place is a mosque, you know the mosque, yeah. So as that place, people they are doing like more activity, so I will select 800. You will find I will show you also how to read the standard. So now you know why we need a standard, to know how to estimate. And even when we come to AutoCAD, I will show you why we need the standards and code. So I will calculate the load using this estimation. Okay. So even this estimation, it is per meter, per feet. I mean per feet square. Yes, per feet square. Okay. So for the feet square, like how much PTU that I need. Okay. So let me show you the equation that we use to calculate the equation. that we use a calculate, it is here. We multiply the A, or the area of the room, by the estimated BTU, or the estimated uh, load calculation that we assume, because here I told you we can estimate between 500 and 800 according to what, to the standard. Okay, you can see here BTU per hour, per meter square, or per feet square. Here even I change it from feet square to meter square. Okay, so it is like this. Even we'll change it to ton. I think you know the ton of refrigeration, TR, which is very popular. Okay, so it is like this. It is like estimation. Okay, it is like estimation. I will estimate. And even in ASHRI you can find like a chapter where you can estimate the fresh air according to the number of the people, according to the places of windows and filtration, the air that going out and in to the building. You can add this information here. Okay, this is like manual calculation. Okay, but here we have like very important thing. We need to select two things. The first thing is the fan coil unit. How can you select it? I will show you where can we find like those devices. Actually, we are using the catalog. Let me show you one of the catalog. Here I will show you the Betra. Maybe you know Betra. Betra is like the Betra, which is a company. Even we have LG, for example. Let me show you the example here. LG, because it is provided many types of HVAC. Okay, this is like the technical information. This is LG, one of the company that you can use to select. Even we have here rack. Yeah, here this is Betra. This is Betra. So when you come to Betra here, I will show you in this course, because when you come to select your device, you will find that we have two things. We have like the sensible, we have the sensible heat, and even we have the total heat. So how you can select it, that what we will know during this course. And even we have the inlet temperature, and also we have the entering well bulb temperature. We will use all this information to know how to do that exactly using the real catalog here. It is Petra. I think you know Petra. It is like very popular. This is the sample here of Petra. Yeah, this is this one here. You can see it. It's Petra. Yeah, we'll do that. So generally, this is the HVAC. This is the HVAC project. Also, we will talk about the diffuser size. How you can select the diffuser size. We use this Magna. First, we use this Magna. This is also one of the catalog that we can use. It's Magna. Okay, this is this Magna. Okay, even you can find like many an information about like the noise criteria. Here we have like information about how can you select it. Okay, here we have a Magna. Magna, it is according to doctrine. You will select exactly the device or the duct that you need. Yes, HVAC duct system inspection guide. This is relating to duct. Okay, so according to SMAGNA, you will be able to know exactly the size of diffuser according to noise criteria. What is a noise criteria? Let me give you one example. For example, for residential building, it is said that according to ASHRAE or according to SMACNA, the noise criteria shouldn't exist than the range of 35 decibel and 45 decibel. You shouldn't exist than this range. So when you come to select your duct, you should take that on your consideration. The duct and even the diffuser, the air terminant. Here I'm talking about the air terminant. Okay, so this is the first sample. This is how we do the manual calculation. I will take you through this process until you know how to do that. This is the first sample. Let us now talk about another type of manual calculation. Okay, manual calculation. Let me talk about the electrical. So for electrical, the first step is to make the lighting fixture schedule. We'll use like a program or software which she called Dialogues. I think you know this one, Dialogues. It is a software that you can use to estimate your lighting devices and to select exactly. So when you select them, you will write them on table to tell me exactly how many devices that you use and which company. Even this is like the names of the company that you have selected your lighting devices from. Okay, this is the name of the companies and all the lighting devices that you use according to that software dialogues. Okay, so here you can see the lighting plan. I will teach you as well how you can connect the lighting devices with the switcher. Okay, and even how you can create the circuits until you reach the final panel. Here we have the final panel. Okay, I'm talking here about the lighting devices. Here what you are saying here, it is the fan coil unit. Okay, so this is the lighting plan. Even you can print it. This is the lighting plan for my building. As well, we have the power plan. The power plan, we can try to draw the electrical circuit for the sockets. Yeah, here. Even we have like some special like requirements here in the electrical project. We are working according to the code of IEC, International Electrical Code. So they have like some of the rules that you have to follow. For example, they are saying that in the standard, the distance between two sockets, it's supposed to be, it shouldn't exist than 20 feet. This is according to uh, International Electrical Code. You should know that when you work on the project, you should know that you are working according to IEC and this distance supposed to be like this. Okay, and even about when you are working on kitchen, for example, if I have, for example, this is a kitchen. You can notice here, this is a kitchen. That's why I have separated one of the socket to be individual and for others to be on one circuit. Okay, so this is how we do the work according to standard. So Also, we have the single line diagram. Line diagram. As I told you previously, this building is 10 stories or 10 floors. So now the question, how it will be like the connection methods for all panel. Those are panel. Okay, those are panel. And even here I have the main distribution panel, final distribution panel, and transformer, generator, ATS. You will know how to do that, how to draw this plan using AutoCAD. And even here we have like let me just try to, yeah, let me try. This is the power schedule for electrical system. This is like one of sophisticated level. If you know how to make this, that means you have become like a professional in electrical. It is to balance or to make the balancing between the loads for the three phases circuit which will be on the panel. And by the end of this table, let me show you the end of this table. Here I have the total. Let me just try to let me just to try here. You can see here how is those like similarly those the total loads of the three phase. This is phase A. This is phase A on the final distribution panel. This is phase B. This is phase C. I have done that manually to be sure that they are at the same range and the differences between them are not that much. It's not that much. And even the size of the final distribution panel and the main distribution panel, the circuit breaker. I have some equation to calculate the circuit breaker. Okay, this is how look like. You will come to draw the single riser diagram. Okay, this is a single riser diagram, and the previous one here, it's called the building riser diagram. They have like, this is a building riser diagram, and that one is a riser diagram. Okay, this is a riser diagram where you can put, like the size of circuit breaker, the sizes of all your cables. Even we can do what we call the cable sizing. You know the size of the cable. Yeah, this here, cable size. This is how it is look like the electrical project. Okay, now I showed you the manual calculation of electrical project, the manual calculation of the HVAC. Let me show you the plumbing. The plumbing, it's here. Plumbing manual calculation. This is the same plan that I'm working on. Okay, this is a small building just to learn, because here we are working like to give you like the first information which you can depend on, and after you learn this you will work on more bigger building. But for the first you should work on more like small building. When you learn the calculation and the way that you do the design, so you can try to work on bigger building. Okay, so here how it is look like. uh, the plumbing connection. This is a heater, this is a WC. You should know how to connect them. Okay, how to connect them. After that, you will try to put the tank on the suitable place, and you will distribute the water. You will connect the water to the risers. Okay, here you will draw the roof tank, underground tank. Okay, even we have underground tank, filter, pumps. Okay, this is a riser diagram. This is the most important thing for the plumbing. a plumbing engineer. Okay, when you know how to draw this, that means you became like more sophisticated. Okay, this is how it is look like. You will draw it, and also you will use some calculation to calculate the pump. You found here the pump, it is zero point 0.8 horsepower, so we will select it one horsepower. We have some calculation to do that, and even we will try to make like manual pipe sizing. Okay, manual pipe sizing in this stage. Make manual pipe sizing. Okay, manual pipe sizing. Okay, this is how it look like, plumbing. Just allow me to show you. Yeah, I forgot something. And even we have the drainage system. You will know how to connect them, how to connect the lavatories, how to connect the WC, the manhole, the gully trap, all of that you will know. So even allow me to show you something about plumbing. Therefore, we have like some people, they think that the plumbing system, it is just the hot water and the hot water system and cold water system. Allow me to show you briefly how many type of plumbing system that we have. Let me just to go faster. We have the cold hot water. Okay, this is the first system. Actually, we have more than 20 uh, plumbing system. We have the cold and hot water. We have the supply drinking water. We have the firefighting system also, as well as related to plumbing system. We have the drainage system also, as well as is a part of plumbing system. So when you are a plumbing engineer, you be suspected to know how to design all those 20 systems. This is the mindset that I want to give to the new engineers or the new designers. You should have the mindset of the project manager. That means you can be able to deal with all those systems such as HVAC, firefighting, plumbing, electrical. You will know because when you become like project manager, you should work with subcontractors, with contractors. So you should know exactly how to design, how to understand the technical. We have the storm water system, we have the sanitary, we have the medical gases as well. So imagine, for example, if you are a plumbing engineer and they the company they ask you to design this system, medical gases system, what you should do? Just you should do three things. First, to know the component of this system. For example, it has like cylinders, pipes, and what the type of pipes that they use. This is the first thing that you should know. Secondly, how is this system operating? The way of operating also to design that system, you should know how it works. Okay. The third thing, you should go to standard and the code to see exactly the requirements of that system, how it will be. Even we have many types: pneumatic, natural, swimming pool, and even irrigation. This is what I wanted to tell you. We have many systems. You should have the mindset to be able to design any one of them, just to go back and read in the standard to see how is it, how can I design, how can I use the software. Okay, this is about plumbing. So we have even the firefighting. Let me go and show you the how it look like. It is here, the firefighting manual calculation. Okay, Here we have five strategies. The first strategy is to make like a resistance wall. For example, if we have like an accident or our fire inside the building, we should try according to here we are working according to, let me just write the name of this is standard. Here we are working according to NFBA. This is an American standard, NFBA. We will know exactly how to select those walls. Like for example, here we have the living room. It will be participation wall rated for 1 hour. That means these walls are protected against fire for 1 hour. But we will focus more on stairs, lift. It is like this. This is the first strategy for the firefighting. The second strategy, even we will use like smoke exhaust system for the stair. Okay. After that, here we have what we call the alarming system. We have cold point, smoke detector, heat detector, sounder. We will know according to NFBA how to put them inside the building. They have specific distances. Okay. You will do like you can see here, you will create a report like 24 pages for this for firefighting. Even you should know how to connect them, the smoke detector, how to connect with, because we will have a panel here. It could be a addressable panel or conventional panel according to your system. We will talk about it when we come to firefighting system. Okay. As well, we have the extinguishing. It's They are those devices which we can use to in order to break or to extinguish the fire, to resist the fire to from going to other side, uh, to from the building. Okay, we can use two types. We can use like CO, carbon dioxide. We can use type K. We can use multiple chemical type. We have many of them. Okay, and even here we have internal hydrant. We have a standby type KCA2, carbon dioxide extinguisher. Okay, we will know how to do that manually. Here we have the sprinkler. I think you know the sprinkler. It is a device that uh, that uses water to extinguish fire inside the building. Okay, and how to connect them. Okay, using piping, and how to make like pipe sizing according to NFBA. Also, you will know that here we have all sizes according to NFBA. Okay, now we have finished the first stage. It was what? The manual calculation. Let me as well take you through the second stage. It is the AutoCAD. The AutoCAD. Now I will show you like other samples. We will start from the HVAC. This is the HVAC project. You should expect it to design the same project here. This is the air water system or the central system that I talked to you, I explained previously on the manual calculation. Even you will know exactly, because here we will use hub. We will use hub. I think you know hub. We'll use a hub report to design this system, this air water system. You can see here we have the fan coil, we have the duct. We will use also duct sizer. We'll use pipe sizer. Okay, we'll use as well mass and DAF. Can you read this? Total water flow of pump is 400 19.9 GPM, okay, 28.8. This is like real project. You can see. Imagine if you have on your portfolio or uh, on your profile such this project. This is a project for a hotel. Okay, this is for a hotel. You can see this is AHU. Even you can read here. Riser duct come from AHU in roof with total 8,456 CFM fresh air for ventilation. Okay, and even we have the exhaust system we can use for the toilet, for the WC, as well we can use it for the kitchen to exhaust the air from inside the building. This is how it look like. Okay, and even we have like the duct. You should know, for example, here we have the duct size. You should know like how much the duct size here, and even sometimes the size of the duct can be changed. You can see here. So this is the HVAC project. Okay, let me after this show you the firefighting AutoCAD project. Yeah, it is here. Sample, AutoCAD sample, firefighting. Let me show you the firefighting project. This is a firefighting project here. You can see here we have like the sizes, the sprinklers have been put according to NFBA distances. They have like exact distances. Even you can read here main pipe, and uh, riser comes from the pump in basement is 4-inch fire pump model. This is the model of the pump. We have selected the pump. Here we can use a software which is called Elite. We use Elite to find like the to select the pump here in this stage. As well, we have the extinguisher, we have the coil points, we have here the hose reel here, and as well we have the smoke detector. We use the smoke detector. This is how it is look like. Okay, this is the firefighting. I have showed you the HVAC, the firefighting. Let me show you the electrical project. Here we have the electrical. Okay, this is the electrical for the same building. You can see how is uh, how is the lighting devices are symmetrical, because I have been using dialogues to design this building. Even I have all circuits. You can see here we have like the power panel. Okay, and even here we have that shape or that graph which I showed you. Here you can see the transformer, power factor correction device, MDB, and also you can notice here we have the main distribution panel, and even here we have what sub distribution panel. Okay, here even when you come to the roof, you will see here we have like an electrical panel. Okay, for the roof. For example, if we have the chiller here, and even if we have the AHU, we should put here the electrical panel, yeah, to feed the power. This is how it is look like. Even you can see here we have what we have the sockets. Even you can come and check. You use the we can use the measure to be sure that we are according to standard. This distance couldn't be more than 3.6. You can check here. It is not more than 3.6 according to IEC. This is how it look like. This is how is electrical. Even if we come here, you can see this is dialogues. Dialogues. This is the software that we will use. Okay, this is the dialogues. This is the lux. Even they have a term which you call lux. Okay, this is how it look like. Design like full electrical system. Let us go to the plumbing system, which is here. This is a plumbing. As you can see here, we have the green color, we have the drainage system, the manholes. All of them have been designed according to slope and according to international plumbing code. Okay, because according to international plumbing code, even you should know how to put the fixtures inside the toilet. They have like special requirements according to the number. How can you identify the number of people inside the building? They have many requirements to be followed. After I show you the projects, I will show you how can we follow the standards. Okay, we have here, those are toilets. You can see even we have the water supply pipes or the water supply system. Here we have the cold water, we have the hot water, we have the heaters. Okay, and here you can notice we have the septic tank. Here you can see riser diagram. Riser diagram, it is one of the things that's imperative. If you are a plumbing engineer, and you can design this or you can draw this, that means you are professional, because you need to know the size. They have like special criteria to know the size according to the static pressure, and how to select exact size. We in plumbing we use pipe sizer, and we use also Excel sheet to do that. You can see here we have what, underground tank. As well, we have another riser diagram for what, for the drainage system. You can see how we can make the flower drain, how the lavatory have been discharged. Okay, how is the stack. Okay, and even the size. Here you can see the size. Here this is the stack, the size is 3 inch, this is stack is 4 inch. When we come to the manhole, you can see even here we have the slope of the manhole. We have all manholes have been connected with the slope. Here we have the slope is 1%. Okay, and even the size of the sewer building pipe until it reach, you can notice every time the slope uh, is increased. Every time the slope increases until you reach the final manhole. After this manhole, you will find what? You'll find septic tank. This is the plumbing. So uh, I expect I expected you to understand now why I told you this course is need like more time, because to reach this level to design like those project, you should understand the code and standard. You should know how to read them. For example, you remember I told you the NFBA. Here, this is the NFBA. This is 2018, the version of 2018. When you open it, let me just open it. Let me open this one. As well, let me show you the SBS SBC standard. This standard is related to Saudi Arabia. You can see Saudi building code. Let us, for example, open the page 663. Uh, just I would like to show you something about plumbing, like just one information to understand. Yeah, it's here. Maybe it is here about plumbing. You have here. You can see all this information. Yes, this is about plumbing. So here we have this table, and this table is telling us about minimum number of required plumbing fixtures according to the type of the building. Here we have theaters, and other buildings. So you would know according to the number of male and female how many the numbers of toilets. We have, for example, one toilet per 65 female, one toilet per 125 male. It is like that. So now this is the NFPA standard, which we can use to follow the NFPA requirements for the firefighting system. Okay, when you have the building, you first of all you should know the rank of this building, because according to the classification of NFPA, we have like four types of the building according to the firefighting. We have the light hazard according to the hazard. We have light hazard, we have ordinary, we have extraordinary. Okay, we have light, ordinary, extraordinary. So according to each type, the firefighting system could be changed. So the first thing is to know how can you identify this building. Is it light? So the possibility of the fire to be happen will be low. It is like that. Is it ordinary? So this is how can you use standard. As well, we have the ASHRAE, which we talked about on the first. You have ASHRAE. This is ASHRAE. Okay, this is ASHRAE. You can go through ASHRAE and you will read about any type of the building, and if you want to design for that building, what are the requirements about the load calculation, the load estimation. Okay, let me just show you the first page of this reference. Okay, let us try to see the page here. This is the name of that the name of that reference. It is what ASHRAE. Okay, uh, now allow me to show you like about the jobs or the MEP roles. Uh, what are the rules on NEB field? We have when you learn, for example, when you learn Revit, for example, you will be able to work on project monitoring and management. Even you can use BIM, building information management, using Revit. Uh, after this file, I will open Revit. I will show you how is Revit. So the reference has been opened. Here you can see this is ASHRAE, one of the most important references when you come to HVAC. Okay, so all our work is according to this reference. They are explaining all types of HVAC system. Okay, they are explaining how they work, how to deal with them. Okay, so before I show you the MEP rule, let me as well give you like more information about the HVAC. Let me show you how many type of HVAC, how many type of HVAC system that we have. Let me show you the photos of these systems. For example, here, this is we have this we call C-rack system. We use this for data center or the place where you can find services. This device is it's called service. I think you know it. This is C-rack. Even here, this is C-rack. You can see this is C-rack system. For what? For the data rooms. Okay, this is how it looks. This is how they put it. You can just let me show you something. I don't know if you know this information, but for the C-rack or for the data room, they don't put the diffuser on the roof. They put them on the floor. They have some reasons to do that. Okay. As well, we have the VRV system. VRV system, variable refrigeration flow. This is a VRV system. It could be we have like one outdoor, we call this device outdoor, we call this device indoor. We have one outdoor and many indoors. Here inside you have like expansion valve, which you can try to control on the value of the refrigeration material which could be entered here inside the system. So you will all rooms will be individually according to partial operation. Okay, this is a VRV. This is VRV system. VRV. This is VRV system. As well, we have this is AHU. This is AHU system, air handling unit. This is VRV system. As well, this is VRV. This is AHU system. As well, we have here this is air water system. Here we have inside the rooms we have the fan coil units. We have the AHU for fresh air. You can see here we have the duct for the fresh air to take the air from the room by the retained duct and to bring it again inside the room. You can notice here we have two ducts from the AHU, one of retained air and the other one for the indoor air. And we have the fan coil. This is air water system. This is how it looks like. Here we have all water system. You can see we have the chiller, we have the pump and the fan coil. As well, here we have when you see AHU, that means this is air water system. We have many types of AHU and HVAC system generally. Okay, let us go back to MEP rule. When you learn this course, actually this is not a course. This is like a route or like something that can tell you what to do. Because I don't expect you after you finish this course to just to leave this work. You can create a list of the building, for example, residential building, commercial building, hotels, offices, villas, many types like 12 or 13, and to try every time to post your work, to build your profile, to post your work on LinkedIn, so the employers will see your work, they will contact you. That what I expect you to do after you finish this course. To try to develop yourself even more, to use more sophisticated softwares, because this like a big opportunity or a massive opportunity to get just to by learning new skills, you will get it. Even you can work in a freelancer website where you can get a job like online, you can get like good money using that software. So we have MEP design engineer, MEP coordination, MEP. All I would say all those people they need to use those softwares, AutoCAD and Revit, because if they don't know this software, so how can they work or how can they deal with with these projects, with this MEP project? All works inside the site or on the workplace are depending on plans. So when you know how to do that, how to draw, how to design, so you will get like more opportunity. Here we have MEP design engineer, MEP coordination, when we get all the system done, we'll have clashing. So the engineer who organize those clashing as I will show you on Revit, that we call him coordination engineer. We have MEP BOQ engineer, bill of quantity. He can calculate or estimate the quantity or the price of all materials involving fan coils, plumbing system, the fixtures, electrical devices, all of them. You can do that using Revit. MEP, we have MEP maintenance as well. They know or they need to know how to use those softwares. Imagine if we have like a failure or if we have like a device that we need to fix, to know the place of that device, especially for example, let us say it is a fan coil on the ceiling. How to know that if you are an MEB maintenance, if you don't know how to read the plan, this is also very important. We have also another field, and even it is very new, BMS, building management system, as well that depends on MEB and how to know to design MEB systems. We have low voltage, CCTV, sounders, data system as well. You can do that using Revit. We have the facility manager. It is a manager who is responsible of maintaining all devices inside the building working. We have the MEB site engineer. If you are a designer, you can be easily be MEB site engineer because already you have the enough background. You can design, you can even give like ready plans to your laborers or the people who are working with you to be able to install all those devices. We have the subcontractor. The subcontractor is an engineer who are able to monitor or supervise the labors inside the site. He is a subcontractor. We have the contractor. Contractor, he will need to create one of the plans type. Let me write that name. It's here. The shop drawing. The shop drawing. We need shop drawing. The contractor who will create the shop drawing, shop drawing plans. Okay. We have the project manager. If you want to be a project manager, uh, the project manager, you can say it is like a more sophisticated rule on MEB. So if you want to be you should come across the MEP site engineer, subcontractor, contractor, and even after you become a project manager, you can, if you increase your experience or you become more expert, you can be like a consultant. But the final step in this field is a commissioning engineer. Commissioning engineers, those people, they get like a percent of the project. For example, let us say that we have a project. So that engineer will get like 2% of the budget of that project. Can you imagine that? So to reach this level, you need like more than 15 years like experience to reach this commissioner engineer. Okay, but for project manager, it depends on your experience and how you can use those devices to design and how you are determined to design more wider project. So every post that you post on LinkedIn will help you to get like job. Yeah, this is what I would like to say about this course. Okay, so the last part as well, I would like to show you how is Revit. When I talk about Revit, I have here a sample for Revit. Let me show you the Revit. Okay, now I have opened the Revit project to show you exactly how is it. Can you see now? This is the Revit project. This is a building of 10 floors. It is like office. You can see all devices here. Even you can see them as a 3D. There's many options. Now we are changing the side of view here. You can see from like an angle. Okay, this is, you can see how it will be like more complicated. Those are all the systems. Okay, let me just try to use like the architecture discipline. Okay, for example, let me try to use the architecture to show you how is this building exactly according to architectural. Okay, let me show you how it is. Yes, this is the building. Also allow me also as well to add the level of view to be able to see all the project. So now we will see the chiller, the AHU, the bumps, all have been designed using Revit. This is like one of yeah, you can see here we have, this is the chiller, and this is the AHU. All of them, they have been designed according to the standards, MEP standards, which we have talking about. We have IEC, International Electrical Code, NFBA for firefighting. You can see this is here. This is the tank, the roof tank. Okay, let me just zoom out to show you the building. Yeah, it's here. Can you see? This is a building. So when you reach this stage of designing, I think you can get like strong profile. If you are able to design like those projects, let me show you the project individually. We will start from HVAC, for example. Let us open the HVAC plan, because here in this software they have been divided like HVAC plan, firefighting plan. Okay, this is the HVAC system. We have the HVAC here. You can see here. Just let me use like the real version, realistic. You can see. Okay, yeah. Here we have the ducts. You can see the ducts. Okay, and also we can uh, I can show you the electrical. This is we have here. This is the fan coil. You can see here. The fan coil. It's here. This is the fan coil, and even we have the chilled pipe here. Chilled pipe. And let me as well show you the fresh air system, or the system that is coming from the AHU. It's here, green color. And also we have the exhaust system for the toilet and WC. Here as well you can see the design from the side, from the sides, from side. I mean not from just the 2D. You can see it as 3D. Go to view. You want to see to see how is it from the side. Here you can see. Yeah, this is the duct, and even you can exceed like this to see more like this. Yeah, here we have we can be able to see the duct from the side, yeah. Here we have, this is a return duct. When you click here, you will see this is a return duct. You see in the system here, this is fresh air. Okay, this when we talk about the HVAC system, this is how it's look like. As well, we have there what we have the AHU. The AHU is here. The AHU is here. This is the AHU, and this is a chiller, as well. Okay, so now we have talked about the HVAC system. Let us go and talk about the firefighting system. The firefighting system. Okay, let us open the plan of the firefighting. Okay, you can see here we have what? You have the sprinkler. Okay, those are sprinklers on the red color. You can see this is a project. This is a full project. All those red color are sprinkler. But in the firefighting system, we don't just have the sprinkler. As well, we have what? We have extinguisher here. You can see the extinguishers. Okay, and even we have the hose reel. It is in some place here. As well, we have the call point, all alarming devices. The most important thing, if we try to go to the basement, let us go to the basement to see what is there in the basement. Okay, let us open okay, this is the basement here. I want to show you the firefighting room, because we put it here in the basement and how it's look like. Okay, this is a transformer. This is related to power. You can see this is a generator. I mean, we have also the transformer here. This is electrical uninterrupted UPS as well. This is another device. Let us try to see the fire room using the 3D. Using the 3D, let us just zoom out. I would like to show you the fire room. It is here on the basement. Just I will change uh, the discipline from architecture to be mechanical. So I will be able to see all the things inside the building. Okay, let us just wait the software. Okay, it is here. Let it open. It is here. Just let us try to minimize, to just focus on the basement, because we need to see just the devices on. Let us before we go to have a look on all systems on the side, from the side views. Let us just to see here before we minimize. Okay, yeah, you can see here distinguishers. This is toilets. Let us zoom more to see how they have been installed. Yeah, here you can see this is a WC, and this is how we have used the elbow. Here we are using suspended type. Here you can see all the things. Let us now zoom out. Just we would like to focus on the fire. Let us ZE. Yeah, try to focus just on the basement. Okay, it's okay. So now we can see all the things just on the basement. Okay, we come to this side. Now come and zoom to see how is the fire pump. It is here. This is a fire pump, and you see how it is sophisticated with the gas tank for the diesel pump, jockey pump, and we have the normal pump here. It is a mechanical electric fire pump. Okay, as well here we have the generator. Okay, here we have the underground tank. Now I showed you this is the pump of the plumbing system. Now I showed you the firefighting and what HVAC. Let us see the electrical system. We go here, open the electrical. Because in electrical we have what? We have the electrical, we have the lighting. This is for what? This is for data. When we have the data system, let us go to one of the electrical. For example, let us see uh, what level 1 electrical. Yes, level 1 electrical, to see how is the electrical system. Yes, here we can see the electrical system here. You can see here we have the lighting fixtures. Okay, we have the you can read the name here. Here we have what? This is electrical fixtures like receptacles. So let us check whether this system has been connected or not. Uh, you can click here. This level didn't connect it because here we have power and switch. But let me show you the ground floor because I think I connected that floor. Yeah, cable tray. Even we have cable tray. Let us go. Yeah, this I think this one has been connected to the electrical system. Just to click here. Yeah, it's connected. Just to show you how is it. Yeah, you can see when we come here. So this device, those devices have been connected where to this panel. We have the electrical panel here. Let us see the final distribution. Is it this one? Electrical? No, this is alarm control. Yeah, we have been talking about this panel when we were talking about the firefighting on AutoCAD. Here we have what? We have the EG panel port. So when you come here, they will give you like information about the total connected, estimated demand, like about the real circuit electrical circuit. And even you can see here how is this is connected to another panel here to go to the basement, because you have on the basement you have the main distribution panel there. You can see how is this software is very beautiful. Now we have talked about electrical. Let us see the plumbing. How is the plumbing system on Revit? Let us go to the plumbing. Yeah, plumbing. Okay, we have the plumbing. Yeah, this is a plumbing system. Let us just take a look. Here we have the plumbing system. You can see we have here the WC, and even we have what we have lavatories, urinals, because this is an office building. Okay, it's an office building, and this is how the suspended drainage system has been installed. You can see using slope and everything, supply system. This is a plumbing system. Now we have talked about all the system. Let me just show you the last properties. It is about what you can get like estimation when you put all those materials. For example, if I am talking about schedule and quantities, when you come to air schedule, for example, the air schedule, I mean like air terminals, they will give you all terminals on the project, the sizes and the elevation. Even you can go here to filter. I mean, you can go to the field and you add more. You can add, for example, you can add the system name. When you add the system name, for example, add system name, and after that, okay, system name. You will see the system name. Is it supply? Okay, because we have supply and return. You can see we have supply, returned. This is return. This is return system, and even we have exhaust, fresh air. That's why this is like sophisticated. Even you can use this for B or Q bill of quantity. Okay, let us check if we can add the flow. Yeah, the flow, yes, it is here. Add the flow to see how much the flow. Okay, This is the flow for each air terminal per CFM. Can see that? Yeah, it's here. So let us go to the electrical to see how is it. Electrical, quantity schedule. We have here the air, the apparent current, okay, and even the panel. Here we have the wear size. This is according to American. So you can go and check on the standard. This one is matching like how much millimeters. You can find that. Number of circuits, which is like this. And even you can add something about the loads. If you need to add the loads, number of elements, power connected, uh, about like system type, as system type, click OK. Yes, here they can give you it is you can see the system type when you come to this side. The voltage, the system type, is it power, fail alarm, yeah, all of them power. We didn't add lighting. It is like this. And even we have the mechanical equipment. You can see here, and the plumbing schedule, quantity, the name of the families, and is it system classification, domestic water, sanitary. So the last thing that I would like to tell you is like you can use this software for monitoring to monitor the progress of your project. Yes, that is the last point. Okay, I think I explained all the system. Now you have like a clear vision to this course. Is it going to be beneficial for you? Yes, you can decide now. Okay. Okay, thank you for watching my video, and you are welcome.